Keystone network because there are more than 4 registers are there. So shall we remove these 2 registers because a ratio of these 2. So I think it's not like that, no. So if you see this, this is 2 ohm. So ratio of these 2 or 4 by 4 and 2 by 4. So we can't do this. We can't remove. And the similar situation arises here. Even if this were 4 ohm, you can't remove. Huh? So I think that there should be some minimum of the rules is what you have to follow. Like whatever you think is not a rule, sir. Even if this were 4 ohm, you can't remove. You can't remove because these are being connected, no? Fine. This is so I think in one of the mains exam intentionally the teacher has given 4 ohm 4 ohm. Most of students they removed it. Then they removed this. Then they said okay the 4 ohm 4 ohm 8 ohm 8 ohm answer is 4 ohm. He has given none option because you should not solve. Logically may happen in mains. Tomorrow mains also they may test you because do you know ideas properly or not? The teacher didn't bother to check your final answer like can you apply Visual network or not. Any logical way of testing can be involved here. So there's nothing called like a Visual network here. Fine. So then what is the next alternative method available? Series parallel. Can we say anything series parallel? That is ruled out. Then what is the alternative left over? Branch current method. So you should assume a current I1, I2, then dividing current. So very complicated. Next again, loop current 1, 2, 3, 4. You are going to connect a battery 5. 5 loops are there. So nodal analysis is the only alternative available. Already we defined the potentials, this one. So what we for what is this? Especially girls, huh? Today what happened? Trisha, Lear, Vari Vaishya. Huh? You can't disturb class like this, no? No, it's a to make problem. Instead of bringing so many unknowns, no, just you can. We have connected a cell. Let's assume that one. So let this be 10 node. You can take even lower values. So even you can write 2 volt. If you take 20 volt, okay, the larger values will come. So don't take 200, 300, that one. So you start with 2 volt or some decimal places will come. So it's advisable. Don't take higher values 80, 70. Higher large values you have to multiply, divide. Don't take 2 volt because 2.3, 2.8 again decimal places you have to carry on. You should be very careful in exam. Okay, this if it is like this, so this will be 0 volt. This will be plus 10 volt. I think this voltage is P, D, Q, C. Then so what next? You have to just keep on apply the nodal analysis here. So I'll start like this. So I'll start with VC. VC minus 10 by 2. I don't know which direction current will enter and will leave. So how many are there? C, P, Q, D. 3 unknowns are there. 4 unknowns are there. 4 equations minimum. We have to write it. And then similarly, VP minus 10 by 4. Already VP over, no? VP minus 10, VP minus C, VP minus VD by 4 equal to 0. This is the thing. So let's come for Q. VQ minus VC by 4. VQ minus VP by 4. VQ minus 0. Okay, this is 0, no? By 4 equal to. Last VD is there. So VD minus VP by 4. How many unknowns are there? Four equations, 4 unknown. In exams, that's what you should do, no? Here. So with this, what happen? We'll get the potentials. That one. After getting potential, you are going to get the current in all the branches. So we'll push that current. That current is sent by this cell. Okay, that one. So calculate this directly, this current I. Then what is the effective resistance RAB? RAB should be equal to 10 by I. Will be very lengthy. That definitely solving this. Even branch current also the same thing. More unknowns are 6 unknowns will come. Loop current, 5 unknowns will come. Node analysis, four unknowns will be there.